What causes basements to get wet, what causes a lot of different things, walls to deteriorate, what causes floors to crack, is what's called a false water table. It's called false because it's temporary. It only lasts for 10 days or 2 weeks, and it's weather driven. You get a good heavy rain, and the area on the outside of your walls, what we call the backfill area, fills up with water. The water on the outside forces its way down into the ground and up underneath your floor. And a lot of people see that they have a lot of cracking in their floor. And if you ask them, they'll say, oh, that's settling. That's not settling. It actually is hydrostatic pressure has pushed and has cracked that floor. If you take a look at this crack, you can see it's what we call clamshelling. In other words, the crack has gotten wider. It's not because the floor has just pulled apart evenly. That's how you can tell it was cracked, by water pressure, by hydrostatic pressure underneath the floor, pushing on the bottom of the floor, and if you think about it, lifted the floor up and caused it to clamshell. So this floor is soaking wet. There was a ton of water in this particular basement. This particular customer had 4 different companies come out and give estimates, and for how much water they had, they couldn't figure out how the other ways that were explained to them would ever get rid of their water problem. This is what I mean when I talk about where you manage your water determines just how dry you can get your basement. This water here is filled up all the way around the floor. There's a particular type of system that sits right on top of the footing, and I have a piece of it here. So it would sit there, and you can see the water is sitting right up next to it. So if the water level is here, the whole floor is sitting in water. When you're looking at this pile, what jumps out is that of all the odds and end pieces, you got about an 8-inch piece, you got another little piece, you got corner pieces, you got one that's about 1.5 feet long, another one about 2 feet long. And it was all just hodgepodge together. It was like scraps all put together, trying to form a waterproofing system. Everything about this for this type of foundation is just wrong. Of all the things I've seen in basement waterproofing, this is as far-fetched and as ludicrous as anything I've ever seen. Which falls into what a lot of waterproofing ends up being is make it look good no matter how bad it works. But this is never a way that you'd ever want to spend money in order to repair a basement wall crack. We're pumping a hydroactive gel, and that gel goes through the crack, and you've noticed we have grease fittings periodically going up the wall, and it will go through the crack from the inside of the wall all the way to the outside of the wall. Different foundations throw different things at you. You have a standard foundation, has a 16-inch wide footing and an 8-inch wall. If you put the 8-inch wall in the center of a 16-inch footing, you have a 4-inch ledge on the outside. It's not the important side, but the ledge on the inside is what's really important. And your floor is poured so it goes over and it sits on top of that ledge. And where the wall sits on the footing, it's called the cold joint. It's where of dry cement, the footing had wet cement, the walls sit on top of it, and then the wall dry. That seam is called a cold joint, and water passes through it. Okay, so we've taken our flow channel, and now we've cut it so that, and we can bend it so that it'll fit right into that cold joint angle right there. So our flow channel is in. We're going to be setting up our pipe and our stone. And if you can focus on just how much drainage that we're installing and where we're installing it. Where you want to manage your water is within the depth of your footing, between the top of the footing here and the bottom of the footing. This area here is what we call the magic zone. If you set up your drainage so you're managing your basement water in this area here, you're creating a complete dry area underneath your floor. No water, if your drainage is all down here, no water is going to fill up any higher than that. Most important aspect of any subfloor water management system is the pitch and placement of the pipe. It's got to be pitched, but it must be done so in a way that it always stays within the depth of the footing, within that magic zone. So super important point is that we want to get back that proper thickness of the floor. Magic number is 3.5 inches. We have plenty. We have plenty here. We have plenty here on the side of the spacer. And as we go around and test, we have plenty of floor that's going back completely code compliant all the way around the foundation. We've put our super slurry up 24 inches up the wall that's going to grow through the wall from the inside to the outside and turn that whole portion of the wall non-porous so it can't absorb any water. As we go down, we have our pipe and stone. We'll just take a look to see where our pipe is. We'll dig down and you can see we have a whole lot of stone in there. And then we're getting down to the top of the 4-inch pipe, which is also on top of stone. So we've created around 10, 12, maybe even a little bit more inches of drainage. What we've also done too is with our engineering tabs, we've kept the full body of the floor on that footing and then still holding the walls out and in place. And we're going to re-cement with our Supercrete product back to the full thickness of the floor. It's a whole lot more work, but it's the right way to waterproof your basement. Now, we have some proprietary products and we use a much stronger concrete, and our concrete actually grows into old concrete. So it goes to a great extent of actually giving some of that structural support back to the floor. Okay, so when we're done, it's going to be in a lot stronger condition than it was when the gutter system was in here, and the floor is going to be back to the full thickness, a full code compliant thickness of a minimum of 3.5 inches. And you'll see as we go, there's going to be pipe, stone, and then we have what we call flow channel, which is a drain board, which will go down the wall and across the footing so that any water coming in underneath the wall will be able to travel through that channel and get right into the pipe and stone, which is pitched around to a heavy-duty commercial pump. Okay, so our sump station is going to go in this corner. So we're going to go in here, and from the far back corner is the high spot. It's still way below the bottom of the floor. Pipe and stone, as you can see, is set up coming around, and it's going to be going into the basket here. And you can see where the holes are in the side of the basket, which holds the pipe itself. This is going to be surrounded by stone and be its own collection area. And then, as you can see, we're re-cementing this floor right back up so that it's level with the main body of the floor, and then with our discharge line coming up, out, and going out away from the house. We're able to run the discharge line through the trench and then come up anywhere around the entire foundation and then bring it up and out through the foundation and then discharge it on that side of the house. It doesn't have to be tied to where the pump is. It's a huge advantage because sometimes you want your pump here, but you want your discharge all the way on the other side. So this is a perfect example where we need to have the pump in one area, and ideally we want our discharge line to be in another area. So we don't want to run the pipe coming across the ceiling in case you ever want to finish or anything you want to do like that. Or also because when you're running water through a discharge line, it rattles a little bit and it shakes the floorboards. So a great advantage would be to avoid any type of discharge line going across and being attached to your floor joists and then shaking your house. Our system is perpetually self-cleaning. It doesn't need maintenance. You don't have to flush it out. And we make such a big deal about it that our guarantee warranty states if our system clogs, in other words, our 4-inch pipe clogs with soil, or there's something called iron ochre, which plagues these gutter systems like we just tore out. If it clogs with either one of those, then we didn't install it correctly because our system cleans itself. And if we didn't install it correctly, you got a bad installation, we feel you should get your money back. So we'll return every penny of the entire job, come back, clean the system, and make sure it's working perfectly, and still keep you under the original warranty as though you were never refunded. We also will allow you to transfer that warranty if and when you ever sell your home to the next owner for as long as they own their home. Pretty impressive compared to having to pay every month for the rest of the time that you own your house just to keep up with your maintenance on your waterproofing system.